Alright, C&D periods, this is it. Last of these most exciting videos. This is investigation 2. So I am not going to be in class on Thursday. I do have to do jury duty. And I am giving you time in class to work particularly on this investigation. So hopefully you'll either see this before you go into class tomorrow, but otherwise there should be Chromebooks available for you if you have questions to look at this most interesting video. So I'm looking here at the distributed property, which we're going to talk more about the definition and vocab on Friday. But the name of this investigation is the same and different. And we're going to get to equivalent expressions, something we've used, a word we've used many, many times. And this investigation is talking about equivalent algebraic expressions. So, boys and girls, it's time to play a game of What's My Rule? It's a game that you'll be playing through 7th grade and 8th grade, and I bet you into 9th grade, so you might as well get used to it. Here it comes. What's my rule? Here's a table. When you get to 8th grade, it's going to be called an XY table. X is the input, Y is the output. Right now, we're just calling it an input-output table. I put a number in, I do something to it, and I get a result. Input, output. So we have to figure out, well, what exactly are we doing to that number in order to get the output? If I input 1, I do something, some rule, and I get an output of 8. If I put in 2, I do something, and I get an output of 11. And if I input 3, I do something, and I get an output of 14. So let's fill in the table, and let's fill in, we've done this in class before, and let's fill in the steps, and maybe then we can figure out the rule, which I think you can. So I have 1 and I have 8. These arrows are how do I get from 1 to my next input and how do I get from 8 to my next output. So I have to fill in the inputs and the outputs before I can fill in anything over these arrows. My second input is 2, and then once I input 2, I get 11. My third input is 3, and my third output is 14. How did I get from 1 to 2? I add 1. How do I get from 2 to 3? Shocker of shockers. I add 1. How do I get from 8 to 11? I add 3. And how do I get from 11 to 14? I add 3 again. So hopefully you've seen the pattern. Again, we've done this in class, so this is like an XY table, only we're calling it an input-output table. What's the differences between 1 and 2? We labeled them. What's the differences 2 and 3? So these here, you're going to fill in with differences of 1, differences of 3, and labeling the arrows. As you can see, spoiler alert, the rule for this game is 3x plus 5. And it says, where does the 3 show up in your table? And hopefully you'll see. It shows up in the output. It's the difference between the outputs. So a lot of algebra is trying to find patterns. And we talked about coefficients and a little while ago, and we'll talk more about it as we get into linear relationships. I want you to notice that the coefficient is the same as the difference between my outputs. So as I look down here, now I have all sorts of other already filled in tables. Here's another game of what's my rule. Here's my inputs, 0, 2, 3, and 4. And my outputs 2, 10, 14, and 18. And hopefully you're noticing here a couple things that are different. One, my difference between my inputs is not consistent, and the difference between my outputs is not consistent. I have a couple consecutive inputs, which just means consecutive means one right after the other. So consecutive numbers are 1, 2, 3, 4. Non-consecutive numbers would be 1, 3, 4, 5. I skipped the 2. That's why it's not consecutive. So if I'm looking at the consecutive inputs, I see I have a +1 difference. These are not consecutive. So hopefully what you're seeing is that there's something missing here. I could add another input if I really wanted to, and I do. So if I put in a 1, here I know my consecutive inputs are +1. So I could say, well, I'll cross that out, +1, +1. And if my consecutive outputs are plus 4, and here it's plus 8, then if I added that in, it's got to be plus 4, and then plus 4 again. Remember, here's my output, my y value. I'm going to give you this little preview of slope. Here's my input, 4 over 1. That's going to be my coefficient. So what number times 0 rather, times 4, plus or minus what number gives me 2? That's where you're starting from. You should be able to figure out what the rule is. Once you've figured out the output differences, that helps you figure out the coefficient of your variable. And then once I have the beginning of it, then I'm just using my input values. 1 times 4 plus one number gives me, if I'm using my output 1, that'd give me 6. 2 times 4 plus one number gives me 10, and you want to see if it works all the way. I'm not going to give you the answer because it is super secret. Okay, and then I'm going to have you look at the cartoon, because cartoons are always fun to look at in Impact. Here they are. Kaya and Maria. I love here where they're using exclamation points in basically all of their interactions, and I'd like to see that level of excitement about math discourse and discussion when I see you on Friday. I don't know if I will. Here, wherever this is, I'm going to call her Kaya, talks about her rule for Luis. Says data would be double the input and then add 6. But Maria says, oh, add 3 to the input and then double it. And Luis says, but neither of them is my rule. It's all very fraught with tension. So if you take a look, though, and I'm going to actually put you back to the investigation, we're going to look at how you can break this down to show that these two expressions are actually equivalent. They mean the same thing. Any value I put in for k in either expression will yield the same result, which means I'll get the same answer. So I'm going to show you how to prove that a number written in parentheses, something written in factored form, can be equivalent to what's called its same expression written in expanded form. I'm starting with 2 times k plus 3, and I'm going to just rewrite that as 2 times k plus 3. It just means I have 2 of these. So let's write that as an addition problem. K plus 3 plus k plus 3. It says I have to have 2 k plus 3's. Well, here they are. It's kind of a weird k. That made it worse. K plus 3. All right, don't judge me. So now it says add like terms, and this I want you to notice because we're going to do more of this next week. Like term just means things that go together. And I use circles and squares to really sort of organize what variables go together and what numbers go together. So this will be the first you're seeing of circles and squares. Let me actually try and erase this nonsense here so you can see it better. Let me erase this bad K and this. And let's rewrite this so that it doesn't look quite as disjointed. There we go. That's still bad. Okay, so now I'm going to see anything I have that's a variable. I'm going to make that a circle. So here's my K, and I'm going to include the operation in front of it. It's a little shortcut that we'll learn why that works next week, but right now, trust me. So I have K plus K. How many K's do I have? I have 2 K's. Then I'm going to put squares around my numbers. Try another like term. I can't combine variables and numbers. It's like combining, people like to say apples and oranges, but those are both fruit. So the example I like to say is it's like combining fish and bicycles. And I'll explain why those two don't go together as well on Friday. Anyway, here I am with I have a plus 3 and a plus 3, positive 3, positive 3. 2 3's is 6. So this is my little proof that 2 times 6 plus 3 is equivalent to 2k plus 6. Now, I then tell you, I think I tell you, yep, here you're going to use a flow chart. Think about what happens with the variable. Always start with k. What do you do first? Here. When I start with this expression, starting with k, what do I do first here? And then you're going to answer which one of these adds first and then multiplies, and the other one. And then look, you get to skip problems 2 and 3. And we're going to go right to, and they're good problems, and maybe we'll do them in class, but you don't need to do them for this investigation. So I got about 5 minutes left before this goes out and I completely lose all interest. Now you're looking at these input-output tables, and you're trying to come up with rules, and I hope what you're starting to understand is you don't necessarily need just one rule for a table. You can come up with one rule, like Kaya, you come up with another rule, like Maria, and you come up with a third rule that apparently Luis didn't want to share with us, but there's a lot of different ways to show how I get from my input to my output. A couple tricks. Not tricks. A couple ways to start. Think about what's the difference between my inputs. Think about what's the difference between my outputs. Can I find a coefficient? Can I use that coefficient as the beginning of an expression? And if I did, in fact, let's even look, we'll do number 4 together, or I will do it and you will watch, and then the rest of it you'll do yourself. So here I see that this is +1, and it's the same for each. Here this is +2, and it's the same for each. So I know that at some point I'm multiplying by 2, and it says write a rule that multiplies first, then adds. That's exactly what I wanted to do. I'm going to get that coefficient 2x right there. Now, if x is 0, I have to do something to it to get 6. Well, if I put in 0 times 2, I get 0. In order to get 6, I'm going to have to add 6. There's my rule right there. So let's see if it works for everything else. 1, substitute in for x. 1 times 2 is 2, plus 6 gives me 8. I'll skip to the end. 4 times 2 is 8, plus 6 is 14. So it works. Now I have to think, how else could I write this? Where I would add first and then multiply. Well, this is twice a number and then adding 6. Could I write this with parentheses? I'm still going to be multiplying by 2, right? How do I get 2 x's? I got to start with 1x. And how would I get 6 having to add the same number twice, because it's like I'm multiplying? Well, if I add 3, isn't x plus 3? And I know, ignore this adds first and then multiplies. So let's just look and see if I combine like terms, if it comes up with the same. X plus 3 plus x plus 3. There's my x. There's my 3 and my 3. Well, this definitely gives me 2x plus 3. So I can write that using parentheses as a rule where I add first, because I'm in parentheses, and then I multiply. And then why? Well, I kind of proved it there for you. Doing some of the work for you. Then you're going to do the same thing for the rest of these. You're going to have to fill in some here. They're not going to give you all the information, so you're going to work a little harder. Try and figure that out. And then this last one for 8, let me just make sure we have this right. I'm going through, copying the tables, and it's really 7 and 8. So they're giving you an expression. Here we are. Well, here I give you the output. Let's look really at 8. I'm giving you an expression. And what you're trying to do here is giving me a rule that fits this, where I multiply and then add, and then I add, and then I multiply. So here's my rule. Really, this is how I get my output. But can I rewrite that rule into something else where I add first and then I multiply? That's what I'm asking you to do for this number 8. And then it's the same thing. So you're really trying to find equivalent expressions. Expressions that, did I finish writing? Did I finish this already? Apparently I did. Yes, I did finish it. Just couldn't find the record there. But I'm looking for equivalent expressions. That's what you're going for. I might do a quick video on the last part for on your own, but I think that's it. So good luck, and I'll see you on